All right, let's talk about one of those things in algebra that trips so many people up, combining like terms. It seems simple, but if you get it wrong, everything that comes after can get messy. But here's the good news. Once you really get this, a ton of algebra suddenly becomes way easier. So let's dive in.
So let's just start with the big one. The question that I know has confused pretty much everyone at some point. Why on earth is x squared plus x not x cubed? I mean, it kind of feels like it should be, right? They both have an x, you just add the little numbers up top? Well, no. And we're going to clear up exactly why once and for all.
You see, this is where that kind of logic just completely falls apart when you try to apply it to the real world. Let's say you have 2 apples and $3. What do you have? Well, you have 2 apples and $3. You don't have 5 apple dollars or some other weird thing. It just doesn't make sense because they are fundamentally different items. And that right there is the entire secret.
And that brings us to a super simple analogy that's going to make this whole thing click. So for a minute, let's just forget about x's and y's and just think about fruit.
Okay, let's start with something incredibly obvious. You've got 3 apples, and someone gives you 5 more apples. Pretty straightforward, yeah? You end up with
8 apples. Of course it's 8 apples. This is totally intuitive because you're combining the exact same kind of thing. Keep that phrase in your head.
Okay, but what about this? What if you have 3 apples and 5 oranges?
Right. You can't magically merge them into something new. You just still have 3 apples and 5 oranges. You can't call it 8 oranges. They have to stay separate because they're different.
And there it is. That's the golden rule. If you remember nothing else from this, remember this. In algebra, you can only combine things that are the exact same kind.
So now, let's get into the official math language. We're going to see how this whole fruit analogy translates directly into the world of algebraic formulas. So first off, what even is a term? Well, it's just one of the individual pieces inside a math expression. It could be a simple number like 3, a variable like x, or something like 5x. Think of these as the individual fruits in our big algebraic salad.
Okay, this chart really breaks it all down. 3x and 5x, yep, they're like terms. Think 3 apples and 5 apples. But 2x and 2y, no. That's 2 apples and 2 bananas, different variables. Now the most important one here is that 4th row, x squared and x. They have the same variable, x, but their powers are different. This is so important. Think of x squared as a whole basket of apples, and x is just a single apple. They are not the same kind of thing, so they have to stay separate.
Okay, so we know the rule now. But how do we actually use it when we're staring at a big, messy expression? Well, there's a really simple visual trick for this.
Here's a 3-step game plan that works every time. First, you identify your terms. You're like a detective looking for all the families of terms that match. Second, you group them. I highly recommend using circles or boxes or different colors to keep things organized. And finally, you combine. You just do the simple math for each little group. Let's see how it works. So let's take this expression. First, we hunt for our families. Okay, we've got our x terms here, 3x and a positive 2x. Then we've got our plain old numbers, our constants, a positive 5 and a negative 7. And then, look at that x squared term. It's all by itself. It has no family here, no other like terms to group up with.
So now we just put the pieces together. The x squared term, well, it just stays as it is. For our x terms, 3 plus 2 gives us 5x. For the numbers, 5 minus 7 is negative 2. And there you have it, our final simplified answer. We didn't combine anything that we weren't supposed to.
All right, theory is great and all, but doing it yourself is where it really sticks. So let's run through a couple of quick practice problems. See if you can solve them before I reveal the answer.
Okay, here's the first one. Take a second, look at it. Find your groups, what do you get?
So, how'd you do? Our x terms, 4x plus 7x, give us 11x, and our numbers, negative 5 plus 2, give us negative 3. The final answer, 11x minus 3.
Okay, a little more complex now. We've got squared terms and regular terms, but with the same letter. Just remember the rule, they are not the same kind of fruit. Go for it. And there we go. We take the a squared terms, 2a squared plus 4a squared, and get 6a squared. Then we take the a terms, 3a minus a, and get 2a, and that poor, lonely 5. It just comes along for the ride.
Okay, for our last practice run, we've got 2 completely different variables in the mix. What do you think you do here? You got it. You just treat each variable as its own separate fruit. Group the x's and group the y's. So x plus 2x gets us 3x, and y minus 3y gets us negative 2y. And that's as simple as it gets because we can't combine x's and y's. So let's just wrap this all up. If you can just burn a couple of key ideas into your brain, you are going to be able to solve these kinds of problems every single time without even breaking a sweat.
Here are your anchors. Number 1, like terms must have the same variable and the same power. They have to match perfectly. Number 2, constants, just the plain numbers, are always friends. You can always combine them together. And finally, my favorite rule. When in doubt, leave it alone. It is always better to leave terms separate than to accidentally combine them when you shouldn't. Remember that very first question, x squared plus x? Now you know exactly why you can't combine them. It's not some weird math trick, it's just sorting your apples from your oranges. Master that, and you've just unlocked a huge piece of the algebra puzzle.